All right, let's dive in. Today, we're going to pull back the curtain on Kubernetes architecture. It's one of those systems that's incredibly powerful, but let's be real, it can also feel incredibly complex. So we're going to go on a little journey together, starting with a single command that I bet you've typed 1,000 times.
You've been there, right? You type kubectl apply-f, you hit enter, and a few moments later, poof, your application is running. It feels like magic. But what is that magic really? What's actually happening under the hood to take that YAML file and turn it into a living, breathing application? That's exactly the mystery we're going to solve today.
You know, the best way to get your head around this whole thing is to think of it with a simple metaphor. Imagine Kubernetes has two main parts. You've got a brain that does all the thinking, all the planning, all the big picture decisions. And then you've got the hands, which are the workers that just take the plan from the brain and get to work building things.
Okay, so let's put some official names on our metaphor here. We're talking about the control plane, that's our brain, and the data plane, which is the brawn. Seriously, understanding this split, this division of labor, is the absolute key to unlocking how Kubernetes really works.
So as you can see, the control plane is basically the management office. It's where the cluster's blueprint, the desired state, is kept, and it's where all the big decisions get made like, hey, where should this new container actually run? The data plane, on the other hand, well, that's all the worker nodes. Their job is pretty simple, but it's crucial. Just run the apps, do the work, and follow the instructions from the brain, no questions asked.
So when you run that Kubernetes apply command, where does it go first? You guessed it, straight to the brain. We're going to call this Phase A. This is the part where the control plane takes your request and gets the entire stage set up long before a single user ever tries to connect to your app.
When you submit that YAML file, it actually goes on this little 4-stop tour through the most important parts of the control plane. It starts at the API server, gets saved forever in etcd, then the controller manager spots it and takes action, and finally, the scheduler makes a really important decision about where it should live. Let's break down what each of these actually does.
First up, the Kube API server. You can think of this as the one and only front door to the entire cluster. It's the bouncer, the receptionist, all in one. It checks your credentials, it validates that your YAML isn't broken, and if everything looks good, it accepts your request and passes it along to be stored. Nothing gets into the cluster without going through this front door.
This quote just perfectly captures what the next component is all about. So once the API server accepts your request, where does it put it? Where does the cluster store its memories?
The answer is etcd. This thing is a super reliable, distributed database, and it serves as the one and only source of truth for the entire cluster. It stores what you want to happen, your desired state from that YAML file, and it also stores what's actually happening right now, the current state. And that's why keeping etcd healthy is absolutely non-negotiable for a functioning cluster.
Okay, so our desired state is now safely tucked away in etcd. This is where the Kube controller manager wakes up. This component is basically a bundle of different controllers, or control loops. For example, the deployment controller is always watching etcd. It sees your request for 3 replicas. Then it looks at the current state and sees 0 replicas. So it says, uh-oh, I need to fix this, and it immediately creates the 3 pods needed to make reality match your request. It's the engine that never stops trying to fix things. So the controller manager did its job, and now we have 3 pod objects. But they're kind of homeless at this point. They exist, but they aren't running anywhere. That's where the scheduler comes in. It's like the cluster's ultimate real estate agent. It spots these new unscheduled pods and starts its matchmaking process. First, it filters out any nodes that just can't run the pod. Maybe they don't have enough memory or CPU. Then, out of the nodes that are left, it actually scores them to find the absolute best fit.
Okay, the brain has made its decisions. The plan is set. Now that plan gets handed down to the data plane. It's time for the workers, the brawn, to actually execute the plan.
On every single worker node in your cluster, there are 3 key agents that are about to spring into action. You've got the kubelet, which is kind of the local manager for the node. You've got a CNI plugin for all things networking, and then kubeproxy, which handles the magic of services. Together, these 3 are going to bring our pod to life.
The kubelet is constantly watching the API server. The second it sees that a pod has been scheduled to its node, it gets down to business. It talks to the container runtime, like containerd or CRIO, to pull the right container image. It creates the pod's environment, it mounts any volumes you asked for, and it starts your containers. The kubelet is what turns an abstract idea of a pod into an actual running process on a machine.
So now the pod is running, but it's pretty useless if it can't talk to anything, right? This is where the Container Network Interface, or CNI plugin, comes in. It is responsible for the whole networking shebang. It gives the pod its very own IP address, it wires up all the virtual network connections, and, if you're using them, it enforces network policies, acting like a little firewall at the pod's front door. And finally, there's kubeproxy. Its job is super specific, but also super critical. It makes Kubernetes services work. It watches the API server for new services and their corresponding pods, and then it programs the networking rules right into the node's operating system. And this is so efficient. It means when traffic for a service hits the node, the OS kernel itself knows exactly where to send it, without any extra hops or delays.
So the stage is officially set. The brain has done its planning, the hands have done the building, our pods are running, they have IP addresses, and all the service networking is programmed and ready to go. Now, it's showtime. Let's follow a real user request as it flies into the cluster.
Okay, here it comes. A user's request first hits a load balancer. That load balancer picks one of our healthy worker nodes and just forwards the traffic. As soon as that packet of data hits the node, the kernel itself, using those rules that kubeproxy set up, knows exactly which pod to send it to. And finally, the CNI network makes sure that packet gets delivered right to the application inside the pod. And voila, the response is served.
So let's pause for a second. In that entire journey from the user to the pod, did you notice what was missing? The entire control plane. This is huge. It's probably the most important architectural takeaway. The brain does all that hard work up front so that when real-time, performance-sensitive traffic shows up, the data plane can handle it directly with maximum speed. The brain is for configuration, not for forwarding packets.
This clean separation of concerns, this split between the brain and the brawn, is exactly what makes Kubernetes so powerful and resilient. It basically functions like a really sophisticated autopilot system.
So let's just recap this core loop one last time. The control plane, our brain, defines the destination, the desired state. The data plane, our hands, does the actual work to get there. And those controllers, they are constantly watching, making sure the actual state never drifts away from that desired state. If a pod dies, a controller sees it and instantly starts the process to replace it. This is the heart of Kubernetes' self-healing, automated power. Which brings us to one final thought. We've seen how this system is an incredible autopilot, always correcting its course to get to the destination. But, every autopilot needs a pilot to tell it where to go in the first place. So if Kubernetes is the autopilot, who's the pilot? Well, that's you. You're the one defining the destination. And now you know exactly how the autopilot is going to get you there. Thanks for joining me on this journey.